Hello, my dear students. Today we are going to present the first episode of our chemistry program for General Secondary Certificate. We are going to discuss Chapter 1, which is the main transition element. We are going to discuss the first transition series and their economic importance in our life. So let us start. Transition elements. First, my dear students, we are going to make revision on long form of periodic table. The periodic table, which is called long form periodic table, it consists of 18 vertical groups and 7 horizontal periods. And elements of the same group have the same valence electrons, so having same chemical properties, while the elements of the same period have the same number of energy levels. Now, my dear students, we are going to make revision on blocks of elements. The left side of the periodic table, all the elements end by filling the S sublevel, so we call them S block elements, which lie in the left side of the periodic table, while the elements that their configuration end with B sublevel, they are found in the right side of the periodic table and called P block elements, and elements in the middle of the periodic table that end by filling the D sublevel, we call them D block elements in the middle of the periodic table, and elements that filling F sublevel are found below the periodic table as shown on the screen. So the screen now shows a periodic table which is called long form periodic table, and the S block elements in the left side, and B block elements in the right side, and D block elements in the middle, and F block elements below the periodic table. Now, my dear students, we are going to discuss the types of elements. The elements where their electronic configuration end by Ns from 1 or 2 electrons in the S sublevel, and Nb where the B sublevel takes electrons from 1 electron till 5 electron, we call these elements representative elements or main group elements. And the elements where their electronic configuration end by filling B sublevel that contains 6 electrons, and helium which is 1s2 electronic configuration of it, these elements are called inert gases. My dear students, the elements where their electronic configuration end by filling the sublevel D, where the D sublevel takes from 1 to till 10 electrons, and F sublevel that filled by electrons from 1 electron till 14 electrons, called transition elements. So the types of transition elements are two types. The main transition elements where the electrons are filling the D sublevel from 1 till 10 electrons, and the inner transition elements where the elements their configuration in this series end by filling the F sublevel from 1 till 14 electrons. Notice that, my dear student, that the transition elements includes more than 60 elements, which means that they are more than half the number of the known elements. As shown on the screen, the left and right side are called representative elements, while the last column includes the elements that called noble gases, and the middle contains the elements that called main transition elements, and below the table the elements that called inner transition elements. Now, my dear students, we can make summary for this revision on the long form periodic table, that period number 1, the energy sublevel filled in it is 1s, and it contains two elements and contains two types of elements which are representative and inert gas, and the inert gas in this period is helium, and the last sublevel is filled is 1s2, where in the second period the energy sublevels 2s and 2b, and the number of elements is 8, and the types of elements is 2, and the inert gas at the end of this period is neon, and the last sublevel is filled is 2b6. While in third period the energy sublevels filled 3s and 3b also contain number of elements 8 and types of elements 2, and the last inert gas in this element in this period is argon 18, and the last sublevel filled is 3p6. While the fourth period the energy sublevels in it 4s, 3d, 4b, and the number of elements are 18, and the types of elements 3, and the inert gas that at the end of this period is krypton, and the last sublevel is filled is 4b6. While period 5 the energy sublevels filled in this period 5s, 4d, 5b, and the number of elements is 18, and the type of elements is 3, and the inert gas is xenon, and the last sublevel here is 5b6. While the sixth period the energy sublevels are 6s, 4f, 5d, and 6b, and the number of elements are 32, and the types of elements are 4, and the inert gas that in the last of column of the period is radon, has atomic number 86, and the last sublevel filled is 6b6. And the period number 7 are the energy levels have the energy sublevels filled in it 7s, 5f, 6d, and the number of elements are 22, and the types of elements 3, and this element has no last inert gas in it. Now, my dear students, we are going to discuss the main transition elements, which is the first chapter in our syllabus. The elements where the outermost electrons are filled, the sublevel Nd from 1 electron till 10 electrons, where N is the principal quantum number, which is from 3 to 6, as shown on the screen: 3d, 4d, 5d, 6d. Since the d sublevel is filled by 10 electrons, so d block contains 10 columns. These columns starts from the first column, which contains elements which end with ns2, n-1 d1, to the last one, which ends with ns2, n-1 d10, in which the d sublevel is filled in the sequence as shown on the screen, where period 4, 5, 6, 7 starts with 4s2, 3d, then 5s, 4d, then 6s, 5d, then 7s, 6d. Now, my dear students, we are going to discuss the groups of main transition elements. There are 7 columns belong to B groups, and the other 3 belong to group 8. These groups are 3b, starting with 3b, 4b, 5b, 6b, 7b, and 3 columns for group 8 and group 1b, and ending by group 2b. As shown on the screen, these groups are on the screen now shown. My dear students, we have give reason in this point. Group 8 contains 3 columns. The reason for that, because the similarities between the horizontal elements are more than the similarities between the vertical elements. My dear student, notice that the lower energy levels for all main transition elements are completely filled with electrons, except for the highest 2 energy levels, which are Ns and n-1d, where n is from 4 to 7. Now, my dear students, the main transition elements can be classified according to the number of the outer energy levels and according to the period, giving 4 series, which are: first transition series. This first transition series includes the elements scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, zinc. Their atomic number starts from 21 till atomic number 30 in zinc. These elements fill the outermost electrons in the 3D sublevel, and they are in the 4th period in the periodic table. Look at this screen, my dear student. You find that the lighted part is the first transition series, which starts from scandium ending with zinc. And my dear students, these elements that starts from scandium that has atomic number 21 till zinc that has atomic number 30. In the second transition series, my dear students, these elements are deuterium till cadmium, and these elements fill the sublevel 4D, so the outermost electrons filling the 4D sublevel, where they are found in the 5th period in the periodic table. So, my dear students, the elements are from deuterium that has atomic number 39, ending in with cadmium that has atomic number 48. Now, my dear students, we are going to discuss the third transition series. These elements starts from lanthanum of atomic number 57 till mercury that has atomic number 80. Here, my dear students, the outermost electrons are filled in the 5D sublevel, and they are located in the 6th period of the long form periodic table, starting with lanthanum and ending with mercury. Now, my dear students, we are going to discuss the 4th transition series. These elements filling the outermost electrons in the sublevel 6D, and they are located in the 7th period of the long form periodic table. Now, my dear students, we are going to discuss only the first transition series. Here, my dear students, as shown on the screen, it is the weight percentage in the Earth's crust of each element: scandium, titanium, and vanadium, then chromium, then manganese, then iron, then cobalt, then nickel, and copper and zinc. These elements, my dear students, form less than 7% of the weight of the Earth's crust. So, elements of first transition series form less than 7% of the weight of the Earth's crust, and they are located in the 4th period. Here, my dear student, the lighted part is the first transition series elements. My dear students, their outermost electrons are filled in the 3D sublevel. Now, my dear students, we are going to discuss the properties and economic importance of the elements of the first transition series. Now, we are going to discuss the first element, which is scandium. This element is rarely found in the Earth's crust. This element, its alloy with aluminum, is used in the MiG fighter jets. The reason for that, because it is less dense and hard. And scandium also is used in the TV photography at night, where it is added to mercury vapor lamps. The reason for that, it produces light with high quality, looks like sunlight. The second element is titanium. The titanium element is a strong element with rigidity as steel but less dense. This can be shown in the following activity, in the following video. My dear students, this video shows the strength of titanium. He used different types of elements as aluminum and shows the titanium as it is hard element and can be used for different uses for the hardness of the elements. Here he used a tube not made of titanium, and now he is going to show we using aluminum only as tube, then the tube is not hard but with using the titanium with aluminum. So my dear student, as shown on the video, the titanium with aluminum is hard than the steel, so we can use it for making space shuttle and aircraft. And so we have good reason in it. Alloys of titanium and aluminum is used in space shuttle and aircraft. The reason for that, because it maintains its durability at high temperature while hardness of aluminum decreases. The third point for using titanium is used in dental implants and artificial joints, because it is inert substance, so the body doesn't eject it and doesn't cause any type of poisoning. My dear student, another use for titanium is using titanium dioxide, TiO2, is used in sun protection cosmetics. The reason for that, because its nanoparticles prevent the ultraviolet radiation to reach skin. The next element we are going to discuss its use is vanadium, that has atomic number 23. Vanadium steel alloy is used in car springs. The reason for that, because vanadium gives us steel hardness and corrosion resistance. The second use for vanadium is using vanadium pentoxide. That is used in, number one, the manufacture of dyes used in ceramic and glass industry. And second use for vanadium pentoxide is used as catalyst in the industry of sulfuric acid by contact process or contact method. The third use for vanadium pentoxide in the manufacture of a strong magnetic conductor. The next element we are going to discuss is chromium, that has atomic number 24. This element is a highly reactive element, but it resists the effect of air. The reason for that is due to the formation of non-porous chromium oxide layer, which is formed on the surface of the molecule metals, where its molecules are larger in size than the metal molecules, that prevents more reaction with air, that we call passivity. So my dear students, if we are going to define the passivity, so it is the formation of non-porous layer of the metal oxide on the surface of the metal that prevent further reaction. The second use for chromium is used in plating metals and leather tanning. And another use for potassium dichromate. The potassium dichromate that has chemical formula K2Cr2O7 is used as oxidizing agent. And another use for compound of chromium is chromium oxide, that is used in the manufacture of dyes. So now, my dear students, we have vanadium pentoxide and the chromium oxide used as dyes. Now we are going to talk about manganese, that has atomic number 25. This element is not used as pure metal. The reason for that, because it is brittle. And another use, it is used in the form of alloys or compounds, as ferromanganese alloy is used in railway track. Why? Because it is harder than steel. Also, alloys of aluminum and manganese are used in the manufacture of cans. The reason for that, because they resist corrosion. Now, my dear student, we took 3 types of alloys used aluminum with it. Alloys with scandium for using in manufacture of MiG fighter jets, and alloys of aluminum with titanium in the space shuttle, and alloys of aluminum and manganese that are used in manufacture of cans. So have to keep them hard. Then manganese dioxide, another use for manganese compound. Manganese dioxide is used as a strong oxidizing agent in dry cell. So we took manganese dioxide as oxidizing agent, and we took also potassium dichromate as oxidizing agent. And another here compound for manganese as oxidizing agent, which is potassium permanganate, KMnO4, is used as oxidizing agent, and also it is used as antiseptic for washing vegetables and fruits. Another use for manganese compound is manganese sulfate, which is used as fungicide. The next element is iron, that has atomic number 26. It is used in the reinforced concrete and electricity pylons and knives, pipes, guns, cannons, and surgical tools. Now, iron is used as catalyst in the industrial preparation of ammonia by Haber-Bosch process. And another use for iron as catalyst is used to convert water gas, which is mixture of hydrogen and carbon monoxide gas, to liquid hydrocarbon fuel by Fischer-Tropsch process. Now we are going to talk about cobalt. Cobalt, it is used in the manufacture of magnets because it can be magnetized as iron. And also cobalt is used in the manufacture of modern dry batteries that used in cars. Also, it has 12 radioactive isotopes. The most important isotope is cobalt-60, which is used in the preservation of food, also in the detection of quality of industrial products and detecting cracks and welding connection. The reason for that, because it emits gamma rays which have high penetrating power. Also, cobalt, that its radiation is used in the medicine as detecting and treating tumors. Now, my dear students, we are going to discuss nickel, that has atomic number 28. It is used in the manufacture of nickel-cadmium battery that can be recharged. And the alloy of nickel and steel that characterized by hardness and resist rust and the effect of acids. So we talk about alloys of steel, steel with nickel, and we talked from 2 minutes ago about steel and vanadium. Vanadium steel in the car springs and nickel steel in the characterized by hardness to resist rust and effect of acids. And alloys of nickel and chromium that are used in the manufacture of heating coil and electric furnace. The reason for that, because they resist corrosion when they are heated to red hot degree. And it is used in painting metals because it gives better appearance and also resists rust. Another use for nickel, the finely divided nickel is used as catalyst, as in hydrogenation of oil, to convert it into fats. Now we are going to discuss copper that has atomic number 29. Copper is the first discovered metal, and its alloy with tin called bronze. And it is used in the electric wires and equipment. The reason for that because it has high electric conductivity. The copper also is used in the manufacture of coin alloys. And the compound of copper, which is called copper sulfate, is used as insecticide and fungicide in purifying drinking water. My dear student, we took copper sulfate and manganese sulfate as fungicide. Now the copper compound, that is failing solution, is used to detect glucose sugar. Why? Because its color changes from blue to orange, indicating the presence of glucose sugar in the blood. Now we are going to talk about zinc. Zinc, the last element in the first transition series, it is used in galvanizing metals because it protects them from rust. And zinc oxide is used in manufacture of paints, rubber, and cosmetics. And zinc sulfide is used in the manufacture of illuminating paints and X-ray screens. My dear students, we have reached to the end of our program today. I hope you understood all the points that we discussed today. So until we meet again, my best wishes for you.